Scientists hope that in the future, artificial intelligence could be key to preventing the worst effects of the next pandemic. Dr. Zygmunt Spuk is the co-founder of a tech company which is collaborating with universities and defence to develop wearable technology which will tell someone when they're unwell.
The way we think about it is when you wear these devices, we want to learn the pattern of life. How does your body react when you're just going through your daily life, when you're sleeping normally, when you're eating well, when you're exercising? All the time your body's generating signals in terms of its heart rate, heart rate variability, skin conductance. And what we then do is we get people to subscribe to some kind of injection, like a vaccine, and then induces a kind of reaction in the body. It triggers an immune response. And that means that the patterns of life in your body slightly change in response to fighting that infection. And then we have new data now about what's going on in your body when it's fighting a vaccine. And the idea then is to try to take these two data sets, the data of you having an ordinary life where things are going well, and the data set where your body is fighting an infection, and try to develop an algorithm, some kind of computer program that can learn the pattern of life difference between when you're doing well and when you're not doing well. And the idea then is when you build this model, you can start deploying it as a kind of predictive tool to be able to say, when we start seeing these changes in your body and the pattern of life of your body, it might be an indicator that you are currently undergoing some kind of infection. Maybe you need to take it easy. Maybe we need to pull you out of the situation you're currently in, and so on.
And so the point of this would be becoming aware of this infection before you are actually infectious and can pass it to other people.
Yes, that would be one aim, is becoming aware that you can pass it on, but also just the sooner you become aware, the sooner you can intervene. You know, this project really stems from defense, and the aim here is to enable the Army to be able to operate in chemical, biological, radiological, nuclear environments, or even in situations where we have disasters, we have floods, a lot of mosquitoes are out there, a lot of different pests are multiplying, and the force is out there helping people, but someone could get bitten, someone could start getting ill. You want to detect very early on when people are starting to feel unwell themselves, when you might need to pull them out of the situation to just help them. But apart from these scenarios, they're also just use cases for the everyday individual. Like you can imagine if you're immune compromised, you might want to understand what's going on in your body, or our vulnerable populations, our aged care sector, anybody that kind of wants to monitor their own body and have a better insight into what's going on in their body, especially when it comes to some kind of infection, could benefit from some technology like this.
Yeah, and so your input in this and your expertise is in algorithms. So as far as developing algorithms go, is this one pretty straightforward or more challenging?
It's very challenging, and one of the reasons it's so challenging is that we have to tease apart variations in the signals that we see just for you living your normal life. So for instance, I might go for a jog, I might go for a run, and my heart rate will elevate, my temperature will change. Or it might just be a very hot summer day, and my body is going to respond to that. So there are a lot of variations that are happening all the time, which are not interesting. And we've got to be able to tease apart those not interesting variations from the ones that are actually indicative of some kind of infection. And so this whole challenge actually was under the banner of extracting information from noisy data and being able to advance the state of algorithms, the state of mathematical models to do that. I think it's just fundamentally useful beyond even the realms of this particular project.
Yeah, and so how do you build that, for people who aren't aware of how you build algorithms, how do you build that into an algorithm so this can sift through the data, the noisy data as you describe it, to cling upon the important data that's coming through?
So there is kind of multiple layers in which you address this. And the one layer is you try to apply some mathematical models that already allow you to separate in time series signals when something happens in the morning, when something happens in the evening. So for example, my body is going to respond maybe the same way, but there'll be some kind of temporal delay depending on when I woke up today or when I had my meal. And there are already established methods to try to get rid of that kind of variability. And what you do next then is once you've kind of gotten rid of a lot of variability using established techniques, that's when you start reaching for the machine learning or so-called AI models. And this is where you say, okay, now I've got all this data of people who were healthy before they got an injection, had to respond to and had to have an immune challenge. And I want the computer now to learn its own implicit rules So you no longer explicitly program the computer and say, these are the things you should look for. Rather you say, well, I've got a lot of data of you when you were healthy, and I now got a lot of data of you when you were immune challenged. And now I want the computer algorithm to automatically be able to distinguish one from the other. And this is what the whole field of machine learning is all about. It's trying to help the computer do that.
So what chance of success do you give this project, this overall project? Your contribution is the algorithm, but there are other organisations contributing to this as well.
Yeah, so look, there are actually many successes along this path. So while we have this end goal of being able to generically detect when your body's getting infected, there's a lot of valuable things to do before you reach that ultimate goal. For instance, even right now, from the data that you have, you could have a much better understanding of fatigue. Imagine a workforce that's, people, doctors who work night shifts, who have to be on call all the time, being able to better characterize when they're actually at the limit and potentially having an evidence base to pull them out would already be valuable. So, there's a lot of, as I said, use cases before you get to the point where you can reliably detect infection. There's a lot of other things you can do. And I'd also point out that as part of this project, in developing these algorithms, we're kind of trying to future-proof things, because in parallel to our project, there are a lot of other projects which are solely focused on developing new wearable devices. For example, there are some smart dentures you can wear that monitor your saliva to detect some changes in your body based on your saliva. There are other patches that you can wear that monitor other things about the body. But all of these different sensors are all going to face the same problem, in that they're going to be noisy, there's going to be interruptions in data flow. You're going to have many of the similar characteristics that we are already getting from the off-the-shelf wearables today. So by actually working on this problem, thinking through the ethical challenges, thinking through the regulatory questions that have to be addressed to get a project like this up and running, we are kind of laying the foundation for a lot more interesting work to happen. So as I mentioned, I see lots of wins along the way. Yeah.
Good stuff. And Zygmunt, just before we let you go, I'd like to ask you this question as someone in this field, because this is just an extraordinary field, and we keep on hearing how it's going to change our lives really significantly over the next 10 years even. What's an example that you could give us now of an area or a part of life where you think AI could revolutionise life sooner than we think, apart from what you're developing?
Wow, so there are just so many different industries I can think about. Obviously, healthcare is the most obvious one. Like, apart from our particular project, there's just a lot of activity in AI being deployed in healthcare. For instance, I was involved in a project around trying to predict wound healing. So we have an aging population, people develop chronic wounds. And one of the challenges when you develop a chronic wound is understanding whether your wound is getting better, to what degree is it getting better. Oftentimes, there are a lot of subjective assessments that need to be made about a wound in terms of how much slack is in the wound, how much granulation tissue, etc. And this is quite a burden. Like, it's hard for us humans to look at a wound and give a precise answer to what percentage of it is necrotic, what percentage of it is bleeding. Whereas with these tools nowadays, you can point them at the wound and they'll characterize very accurately how much the wound has changed, if it's getting better or not. And what it means in practice is that people are getting help a lot faster. But aside from this, even just in the industrial setting, there is a lot of work in Industry 4.0 where people are starting to do similar things that we're doing to the body, to machinery in general. So for instance, you can instrument your pumps, your other mechanical equipment with sensors that will tell you very early on that your bearings are wearing out, or that something is overheating. So even if we think about our industries and our ability to produce goods, we are making these things much more resilient by being able to apply these technologies to very early on detect problems. So these things translate beyond people and health. They go actually into machinery as well.
Yeah, well, it's really good to hear some positives about that, because we kind of hear a lot of about how concerning some of these developments could be, and even some of those experts recently concerned about the possible end of humanity if AI went in the wrong direction. So it's really good to hear some positives from you. Zygmunt Spuk, thanks so much for talking to us, and good luck with your work.
Thank you very much.
And sticking with AI in